Well, now we're going to talk about verifying trigonometric identities. And when we're verifying trigonometric identities, this is different than solving an equation. We're either going to just work on one side of the equality or we're going to work on the other side of the equality. And sometimes we'll see that we'll work on both sides, but we're not moving things back and forth across the equality because the properties of equality don't necessarily apply to trigonometric identities. And in this example, we're just going to transform one side of the equation and make those actually equal, and that's called verifying a trigonometric identity. So let's get started. All right, we're asked to verify that the cotangent squared of theta minus the cosine squared of theta equals the cotangent squared of theta times the cosine squared of theta. And on the face of it, that doesn't seem possible, does it? How can I subtract the cosine squared of theta from the cotangent and they equal the two of them being multiplied together? Well, let's get started on this verification process, and we're going to be using our trigonometric identities. Now, if I'm looking at this cotangent, well, we've got a quotient identity that says that the cotangent is equal to the cosine over the sine, and so the cotangent squared of theta is equal to the cosine squared of theta over the sine of theta. And I use that quotient identity right here. Let me see if I can mark on this. We use that quotient identity here in part of our verification process. And so now we've got the cosine squared of theta over the sine squared of theta minus the cosine squared of theta, and we're still questioning whether that's going to be equal to the cotangent squared of theta times the cosine squared of theta. Now, one of the things we may want to do when we're working with these trig identities is we may want to see if we can factor something out. And this is what I've done here. Here we see that we've got I factored out the cosine squared of theta, and that left me with 1 over the sine squared of theta minus 1, which is now we're still working towards see if we can verify that this is going to equal the cotangent squared of theta times the cosine squared of theta. Now, I'm looking here at this 1 over the sine squared of theta. Well, we got a reciprocal identity that says that 1 over the sine is equal to the cosecant. So 1 over the sine squared of theta is going to equal the cosecant. Is going to equal the cosecant squared of theta. And that we see right here. We transform this 1 over the sine squared of theta to this cosecant squared of theta minus 1. Now, cosine squared of theta times the cosecant squared of theta minus 1. We're questioning whether that equals the cotangent squared of theta cosine squared of theta. What can we do? Well, we got a Pythagorean identity that says this, that we'll write it up top, that the cosecant of theta is equal to the cotangent, and that's cosecant squared, by the way, equals to the cotangent of theta plus 1. That's Pythagorean identity. Well, I could move that 1 over to the other side, and then that would leave me with that the cosecant squared of theta minus 1 equals the cotangent squared of theta. Well, look what we got right here. I got the cosecant squared of theta minus 1. And I can use that Pythagorean identity to say, well, the cosecant squared of theta minus 1 is equal to the cotangent squared of theta, which then leads us to our final verification that the cotangent squared, if this is equal to the cotangent squared of theta, Well, then that's the cotangent squared of theta times the cosine squared of theta, and that does in fact equal the cotangent squared of theta times the cosine squared of theta. And we have verified the trig identity by transforming one side of an equation. How about that?